Good day, everyone. When we receive a file and we ask the designer, have you checked the stability coefficient? Usually the answer that we get is something like this, that I have included the p delta effects in my analysis, so why I need to check this? I wanted to create a video and explain this so everyone can benefit from the explanations, and I would like to refer you to BNBC 2020. In BNBC section 2.5.7.9, it says that even if you are including the p delta effect in your analysis, the equation 6.2.49 shall still be satisfied. And what this equation says, it says that your stability coefficient theta should be less than a maximum value for that theta. And this maximum value is something like this. So if your theta is greater than the maximum value, the structure needs to be redesigned. I personally haven't seen this scenario so far, especially in non-sway stories. It is much less than theta max. But considering the practices in DACA that sometimes the contractors use brick aggregates instead of stone aggregates, I think it becomes a bit more important to check this criteria. And also it is mentioned in the code, so we have to check this and satisfy this criteria. Since this specification is here to ensure that your structure will maintain its stability after an earthquake. But before jumping into how we can check this in ETAP software, I want to give some explanations about the sway and non-sway stories and how BNBC approaches this matter. This is important because of two reasons. First of all, if you are not using ETAPs for your design and you want to make hand calculations, sometimes, especially in cylinder columns, you need to increase your moments by a factor, and that factor is a function of sway or non-sway behavior of your story. The other one, in some codes, not in BNBC, in some codes, the modification factor that we use for cracked properties of elements are a function of sway or non-sway behavior of your story. So let's see what BNBC says about this matter. In page 3494, BNBC allows you to use two methods to check if a story is sway or non-sway. The first one states that a column in a structure shall be permitted to be assumed as non-sway if increases in column end moments due to second order effects does not exceed 5% of first order end moments. What does this mean? It means if you subtract the first order moments from second order moments and divide it by the moments from first order analysis, if it is less than 0.05, then your column is non-sway or your frame is non-sway. The other method introduces the stability index Q, and it says if your Q is less than 0.05, your story is permitted to be assumed as non-sway. Please note that BNBC states the story, so this is a characteristic of a story, not a building. So we need to check this criteria for all stories separately. Now let's go and check each of these options in detail. In software language, this formula can be presented like this. The moments that we get from analysis, including p delta effect, and the moments that we get from analysis without p delta effect. And if you remember in the ETAP software, there was an option to include the P delta effect, and if you don't want to include it, you put none, and if you want to include, you put this option and you introduce some loads. BNBC says that if the stability coefficient is less than 0.1, you are allowed not to include P delta effects. But let's have a deal now. Let's always include P delta effect in our analysis, regardless of results of the stability coefficient, because it is not a complex or time-consuming approach. It's just few clicks, and even checking for this coefficient is much more time-consuming than including the P delta effect. So the other option says that Q equals to sum of the vertical loads in one story multiplied by first order relative lateral deflection divided by the horizontal loads in that story multiplied by height of that story. Again, this is characteristic of a story, not a building. So for each story, we need to calculate this Q factor and check if it is less than 0.05. I would like to ask you to kindly take a moment and compare these two equations with each other. You will find that the nature of these equations are very similar to each other. Code also allows you to use service loads to calculate, but you need to make some modifications to this formula. I personally don't like to use service loads, but the code allows you to use it. Thank you. In next video, we will see how to check this stability coefficient in ETAP software. Stay safe.